All right. So we are still doing law of sines. Goodness gracious. This is law of sines. Last night we did angle, angle, side, and angle, side, angle. And right now we are going to do side, side, angle. All right, these are very specific triangles. Okay, so I'm going to give you an example problem just to walk you through it so you guys can see. This is called the ambiguous case. Does anyone know what the word ambiguous means? It's not difficult, but you're kind of on the right track. It means vague. It means vague. So this is the vague case, and you're going to see why in a second. So the information they're going to give you is that you have triangle ABC, where side A equals 5, side C equals 7, and angle A equals 40. And we are actually going to draw this to scale as good as we can. All right, you guys are going to kind of eyeball it. So we're going to draw first this is A equals 40. Okay, first we are going to draw a 40-degree angle. A equals 5, C equals 7, angle A equals 40. Look, I said A equals angle 40.
Yeah,
That's strange. All right, angle A equals 40. Okay, so I'm drawing alongside down here. This is going to be about 7 centimeters. Just do your best to eyeball that. Now, if this is a 90-degree angle, then this would be 45, right? Exactly halfway in between. And 40 is a little bit less than that. So I'm going to do my best job to try to draw a 40-degree angle. I'm not being perfect, I'm just doing my best. Okay, so that right there, it's a little bit less than 7. Actually, this is going to go all the way. Sorry, just kidding. Let that go up all the way. All right, so this is going to be angle A. This is 40 degrees right there. This is side C. That's about 7 centimeters. And I have 2 options for side A. I can have 5 centimeters connecting this way. I could say that that is 5 centimeters. Or I can take that side and swing it in and have it look like this. Do you guys see that? And that's 5 centimeters there. So that means that with this information, with this angle side, it's vague because I don't know if this is the 5 on the outside or if they swung that side in and they're talking about this one. Does that make sense? I've got 2 options, okay? So that's why we call this the vague case, because there are actually 2 triangles you can solve with this information. Not just one, there are 2 sets of information, okay? So what we're going to do is we're just going to go ahead and approach this problem, and we're going to solve 2 triangles. So now I'm going to go back, and I'm just going to label it like I did for my other video, A, B, C, A, B, C. So I'm going to label with the given information, and I'm going to draw 2 triangles. So 40 degrees for A. I don't know what angle B is. I don't know what angle C is. I do know that side A is 5 and side B is 7. Does that make sense? Also, I drew these triangles way too small. So if you drew them bigger, that would be probably preferable. Okay. So I'm drawing 2 triangles, and that's because I am representing one triangle where I had the bigger version. I swung the 5 out. I'm going to have another triangle where I swung the 5 in, and that's going to be a smaller triangle. Okay? All right, so let's go ahead and start the problem based off what we know about law of sines. How should I start it? What information do I have, a side and an angle that match? Yeah, I have the 5 and 40. Those go with each other, right? So I'm going to say 5 over sine of 40 degrees. And the only other side I have is side 7, right? So I have to use that one. And what angle does that one go with? B. So I'm going to say equals 7 sine B. Right? So this is different than the other problems because in the other problems we had 2 angles, right? So to find a missing angle, all we had to do was subtract it from 180, right? Subtract what we had, we could find the missing angle, that was easy. This one, we have to find 2 missing angles. And our angles this time are going to be nasty decimals every single time, okay? So I'm going to go ahead and cross multiply. I have 7 times sine 40 equals 5 times sine B. And then what am I going to do to solve for this B right here? Divide by 5. I can't divide by sine, but I can divide by 5. So 7 sine 40 over 5 equals sine B. And does anyone remember from math 2, maybe math 3, how you get rid of a sine? Sine inverse. So I'm going to sine inverse that side, and I'm going to sine inverse the left side. Yeah. There we go. Right, so I sine inverse each side, and now I am ready to type it in my calculator. And every single one of you needs to be typing this because we're about to get more difficult. Okay? All right, I'm going to turn the light on over here so you can see my calculator. All right, so I'm going to type in. Now I'm going to do this like you would do it if you were a student because you're probably not going to show all this work every time, right? We started shortcut. Degree mode all day today. Okay, so we're going to type in 7 sine 40 divided by 5. So that's what it should look like, right? Because that's everything we would have had. If we were solving the equation like this, that's everything we would have had. So go ahead and press enter. And then we need to take the sine inverse of this, okay? The important part of this is that I know that you guys have worked with calculators in the past and you have rounded decimals and you can do that. We have to get through to the end of a problem without rounding any decimals until the very end. That's what makes these problems hard, is that we can't round in the middle and use a rounded number. We have to keep perfect numbers until the very end, okay?
Put this away and use numbers.
Yes, we're going to store it. That's how we're going to do it. So what I want you to do is you're going to hit second sine, and then I don't want you to pull these numbers down because believe it or not, when you pull the answer down, you guys know how you can highlight it and pull it down? It does not pull it down perfectly. It rounds it when it pulls it down. So we can't pull numbers down, okay? But it's still pretty easy to do. You're going to type second sine. That's going to get sine inverse on your screen. And then you're going to hit second negative sine. And it types up ANS. What do you think ANS stands for? Answer. It's going to pull the answer from the original, but it's pulling the exact answer. It's not just pulling the decimals you can see, it's pulling everything.
What did you hit to do it?
I hit second sine for sine inverse and then second and then the little negative down here. And that's what made the answer pop up. Okay?
Oh.
Second sine, second answer, basically.
Oh, word.
Okay? All right. So when we do that, it went ahead. Now this is a perfect number. This is not rounded. This is the exact decimal as it should be. Okay? So what I'm going to do now is I'm going to write that down.
The whole joint?
I'm going to write 3 decimal places. So angle B is approximately 64.145 degrees. Okay? Do not clear your calculator. Leave that number on there. Yes?
So before you showed us the second sine and second answer, I just went ahead and did second
So
sine.
go back and do it again.
It got the same.
It's going to get it, but you have decimals cut off at the end. And if you ever multiplied it by a huge number, you'd be gone. Your answers would be wrong. Okay? So the reason I'm making you do this today is because you can do it your way by just rounding to some numbers and get like the right full number answer, but I'm going to have you round to 3 decimal places. That is 1/1000. That's 1/1000th accuracy. You can't get that much accuracy with rounded numbers. Does that make sense? You can get a whole number level of accuracy, but you can't get that much accuracy with rounded numbers. Does that make sense? Okay. We are practicing this because in upper level mathematics, the expectation is you do not round until you're done. If you're not done, you're not rounding, okay? The reason I rounded this before I wrote it down is because angle B is one of the things they want to know. That's a final answer. That's why I can round it when I write it down, okay? However, to finish the problem, I have to use angle B, and I have to use the perfect version of it to do my computations. So there's a store button, S-T-O. Do you guys see that?
Yeah.
Hit that button, and I'm going to store this as the letter B, because this is angle B. So I'm going to hit alpha, and see the one that has the green B? So it should say answer goes to B. Okay, and then you press enter, and now every time I press B, 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 it's always going to put that perfect number in for me. Alpha B. Store alpha B. Okay? On your paper, so that you don't forget what you stored it as, because we're going to store several numbers, put a B and circle it. That's the notation we're going to use anytime we store something. Okay? We're storing that for B. All right. Here is how you find angle B in the second triangle. Okay? I'm going to draw an arrow. I'm looking at the second triangle now. And I'm going to do 100.
Yeah, I got fire.
Okay. I'm going to do 180 minus angle B. Okay? So in your calculator, type in 180 minus angle B. Okay, so you need to type in the next problem. Press enter. Did the decimals pop up? All right, so 180 minus B tells me that angle B in the second triangle is 115.855. Okay? Do not clear that off your screen. Leave that on your screen. Okay? So what that means is that for the first triangle, this right here is angle B in the big triangle. This angle is 64. This is angle B in the second triangle. That angle is 115. Do you guys see the difference in your angle B's? Okay, so that's what we just found. We found two angle B's. We are going to need both of those angles to solve the rest of the triangle. Okay, so I can't use B again because then I'll overwrite the answer I already stored in there. So somebody tell me a letter that's not B that's somewhere far away from B.
Z.
Z, we're going to use Z. So go ahead and hit S-T-O, stow. We're going to store that and hit alpha Z, and alpha Z is it's alpha 2. So we're going to go ahead and store that one. Here you can see I'm storing it as Z. I'm writing on my paper that I'm storing it as Z. Okay? All right. If I have angle A and I now have angle B, how can I find angle C? Subtract it from 180, okay? So I'm going to do 180 minus 40 degrees minus the number I have stored is angle B. 180 degrees minus 40 minus the angle I have stored as B. So go ahead. Okay, so what you should have gotten is that the third angle in that triangle is 75.855. Did you get that? Okay. So I'm going to say that this is 75.855, and this right here is angle C. Okay? So before I start losing my information, I'm just going to write all my answers up here at the top. Angle B for this triangle is 64.145. Angle C is 75.855. Okay? So at this point, I have angle A, angle B, angle C. I have all of the angles in my triangle. I have side B and I have side A. What information am I missing? Side C. Okay? So at this point, I need to store this angle in my calculator because this is angle C and I don't want to mess it up. So how do I store this? Store, and I'm going to go ahead and save it as C. Okay. So right next to this, I'm going to write, this is angle C. Okay. So now I'm going to take that beginning information I had, I'm going to take 5 over sine of 40, and that equals side C, which I don't have yet, divided by sine of angle C, and I'm just going to use this notation because that's what I had stored in my calculator. Okay? So with these problems, if you try to memorize this process, that is probably not going to go well for you. You have to understand what the process is doing. Okay? So we're going to finish the problem, and then I'm going to talk you through it and remind you of what we did. Okay? All right. So that's angle C. Let's go ahead and do the math on this. So I'm going to cross multiply. 5 times sine of angle C is side C times sine of 40. And this doesn't represent a variable. This represents a decimal I've stored in my calculator. Right? Okay. And that's Miss Rice notation. That's not like a math thing. That's like Miss Rice does that to remember what she stored. Okay. All right. So if you do this in college, your professor's going to be like, what does that mean? You'll be like, that's the Miss Rice thing. Yep. That's what we did. All right. So how do we solve for side C? We divide sine 40 over to the other side. Okay. So 5 sine of angle C divided by sine of 40 divided by sine of 40. And side C is approximately... So we're going to do 5, there you go, 5 sine angle C divided by sine of 40, and we get 7.543. Okay. All right. Now, we need to repeat some of those steps, but for our second triangle. Okay? Right, because we've got 2 triangles. So this is the information we found for the first one, but now we have a second triangle. So the second triangle has the same first 3 pieces of information, but the other 3 pieces of information that we find are completely different. Okay? So this one had angle B that was this other decimal. So we have angle A is 40, angle B is 115. How do we find angle C?
Oh, okay.
Yeah, so 180 minus the 40 minus what we got for angle B. Okay? And yeah, we're going to call it Z. And I still have it stored in my calculator from before. So we've got 180 minus 40 minus angle Z is 24.145. 24.145. Did you guys get that?
Yeah.
Okay.
24.145, right?
Yep. Okay, and that's my new angle C. And I need to store that. What letter do you guys want to store it as?
K.
K. So we're going to store alpha K. All right. So now what we want to do is we have angle A, B, and C. We have side A. We have side B. We need to find side C. How do we find side C?
Same thing.
We take that original fraction that had the angle on the side that correspond where we knew those numbers. So we're going to take the 5 and the 40. 5 over sine 40 equals C over sine K, because that's the letter that we use to represent angle C on this problem. So we had to store a lot of numbers. Are you guys recognizing that? So the hardest part of this problem is not necessarily doing the math. It's keeping the numbers perfect as we go. Okay. All right, so I've got 5 times sine k equals c times sine 40. So I'm cross multiplying, and what do I do? Divide by sine 40. Divide by sine 40. And this is ready to plug into my calculator. So 5 sine k divided by sine 40. And for this one we get 3.182. 3.182. Okay. These were centimeters, so I'm going to go back and label that my sides are centimeters.
Wait, what?
So where I put my final answers, I just went ahead and on both of those I labeled that side C was in centimeters. Okay. So here is the process. I'm just going to remind you of what the process was. Okay. So we started the law of sines like we would start any law of sines problems, where we took the side and the angle that went together, right? And then we have to look at the other information that we were given. This is the only time in law of sines that the first thing that you're solving for using the law is an angle. For the other two situations that were easier, you were always solving for a side first. So the ambiguous case specifically is solving for an angle first, and that angle is the key to the problem. Okay? So I found angle B first, and I subtracted it from 180. So I got the angle B for the first problem, I did 180 minus that angle, and that became my angle B for the second triangle. Does that make sense? And I am storing everything. That is the only difference from the other problems. That is literally the only step that is any different. Okay? From there, it's just like the other problems. You just have to finish it. Does that make sense? Okay, so what I would do is I'd find this on your paper and I would say like this right here, I'd maybe put a star next to it. That's the step that's different, is where we get the two angle B's.
But
Okay.
didn't we already have like sines, the side C thing?
In the original so what I accidentally did is I switched sides B and C when I wrote the triangles again. Yeah, I switched them on accident. Okay. We are going to go ahead and start working a little bit more in that packet. So, go ahead and grab your packet.
Wait, I have a question. How do you clear all of these out of hour numbers?
So, if you want to clear all these stored numbers, you can do second plus 712.
Yeah.
But every time you do that, you're going to have to put your calculator back into degrees.
Yeah.
So, the thing about this is, listen carefully, if you have stored a letter for A, the next time you store a letter for A, it will just overwrite the one you had before.
So what would you do?
I just leave them in there until I use the letter again, and then I store something over it. I don't clear it every single time.
What happens to the one that's there? It goes away?
It goes away. All right. So here, these problems, listen carefully, these problems are starting you off easy. They are not going to ask you to solve the entire triangle. They're just going to say, tell me the two different angles I could have. Okay? So we're going to go ahead and try that first. So I'm going to take the information given, and I'm going to set up the problem. So what are the two pairs of information I have that can set up my law of sines? So I'm going to say 7 over sine 26 equals, 15 over sine B. Okay?
What are the two angles?
Right? Is that how we did on the other one?
It's side over angle. This is a side. 15 is a side. These are different than the problems we did before because they were easier.
But on the ones before.
On the ones before, we were always solving for a side first.
Okay.
We are solving for an angle first here. Okay, so I'm going to cross multiply. I have 15 sine 26 equals 7 sine B. And then what do I do? Divide by 7. Okay, so I'm going to start typing this in my calculator. 15 sine 26 divided by 7. So sine B equals that decimal, right? 0.939. This is not my answer for angle B, though. How do I get my answer for angle B based on that decimal? You don't have to store it yet. So I'm going to do inverse, okay? So sine B equals that decimal. I need to do sine inverse to get the B all alone. So I'm going to hit second sine, second answer. I'm going to do sine inverse of that decimal. So my first angle B is 69.945. 69.945.
I forgot, how do you do it?
Okay? And you can store this. So store as angle B. Store alpha B. So I think we used B already on the previous problem. When we store this as B now this number has been stored instead of the other number. They forgot the other number. The calculator ditched the other number. It's using this one instead. Okay? And now we do 180 minus angle B. 180 minus angle B. And so the other angle B for the other triangle is 110.055. Okay? And you're done with the problem. That's all they wanted you to do. So some of the problems ask you to solve the whole thing. This particular problem is saying don't solve the whole thing. I just want you to find the two different possible B's you could have. Okay? And then move on. Okay? All right, so let's start the next problem and see if we can do this more easily than we did that one. Okay, how do I start it?
Your sides, the ones that match up.
The ones that match up. So 17 over sine of 16 equals 24 over sine of C. So 24 sine 16 equals 17 sine C. Okay, so 24 sine 16. Sorry, I'm trying to be zoomed in, but make it so you can see what I'm doing. Okay, 24 sine 16 divided by 17. This decimal equals sine C. And then what do we have to do to this decimal? Inverse, sine inverse. So sine inverse, second answer. So I'm doing the inverse of the decimals I just got. And I should hear you typing because you're practicing it too. This is like different than what we've done before, so we need to practice it. And so the first angle C that I get is 22.901. 22.901. What do I do with that? Store it. So store as C. And then what do I do for the next one? 180 minus C. Okay, so if we start problem number 5, how do we start it?
The same way we always started.
Same way we always start it. So these two go together. So we have 92 over sine of 42 equals
B over
120 over sine B. Okay. How do we solve for angle B?
divide.
Cross multiply, so we have 120. We have 120 times sine of 42. And, hold on, let me actually write what I'm doing. So I have 120 sine 42, and I'm going to divide it by 92. So sine B equals that decimal. And then what am I going to do with that decimal? Sine inverse. All right. And so my first angle is 60 point. So angle B is 60.783. The other angle B is 119.217. Okay.
Isaac, can you pull it just a tad? I can't see.
So for us to figure out how many triangles there are 3 options. You could have 0 triangles could be built. If you have 0 triangles, that means that when you solve for angle B, you would get an error message. So if you ever get an error message, you'd be like, oh, that triangle that's not a real thing. That triangle can't be made, okay? You're always going to get 2 answers for this. You just have to use your common sense to see if those answers make sense, okay? So if we have a 42-degree angle, does it make sense that this could be a 60-degree angle and I still have room for a third angle? 42 degrees, 60 degrees, something adds up to 180? Yep, so that one makes sense. If this one is 42 and this one is 119, do I still have room to make a third angle? Yes. So this one has 2 triangles.
So it has 2 triangles just because you got the 2 angles?
Yeah, because you have 2 different angles and both of them make sense. You can use both of them, okay? We're going to see the difference because in number 6, you can't have 2 triangles, and you'll see why in a minute. So let's go ahead and work on number 6. I'm doing your homework for you. You're welcome.
Thank you.
All right, so for number 6, ready? 24 over sine 38. 6 over sine of D. It's inappropriate for us to be chatting right now because I am literally recording a video of notes for you guys. Okay? Should not be talking. All right, we're going to cross multiply. 6 of sine 38 equals 24 of sine D. And so for me to solve for that angle, I'm going to have 6 times sine of 38 divided by 24. And sine inverse tells me that angle D could be 8.854 degrees. And then what is the second angle you could have? 171.146. Are we okay with those 2 angles? Are we getting to those?
I'm getting to those.
Okay. So keep working until you can get to those 2 angles. And then if we look at the triangle that we have, it has a 36 or a 38 degree angle. So does it make sense? A 38 degree angle here, an 8.8 degree angle here, and then I could fill in a missing angle here. Could I possibly do that? Yeah. Okay, so this one's okay. Could I have a 38 degree angle here and then a 171 degree angle here? No, that angle does not make sense. So this one is kind of like an extraneous solution. Mathematically, I can find it, but it doesn't make sense. Okay? So I'm going to say that's extraneous. That means that even though I was able to see that it was angle, side. It was a pain in the angle, side. It was the ambiguous case. There's only one triangle. And that is what makes this case so frustrating, is that anytime you are given angle, side, you can't automatically be like, oh yeah, let me solve that triangle. You can be like, well, let me start. It could be one triangle, it could be two triangles, or it could not even work at all. That's what makes it vague. That's what makes it ambiguous. Okay?